Have you ever wondered why earthquakes occur in some parts of the world more than others? Well, let's delve into the mysteries of the Earth to find out. Our planet isn't just a solid ball. It's more like a jigsaw puzzle. This puzzle is made up of massive rigid pieces known as tectonic plates. These plates form the Earth's outermost layer, the lithosphere, which is not one solid piece, but is broken up into numerous puzzle pieces. These pieces drift on top of the semi-fluid layer beneath them, called the asthenosphere. The movement and interaction of these plates give rise to much of the geological activity we witness on Earth's surface. From the highest mountain peaks to the deepest ocean trenches, from fiery volcanoes to trembling earthquakes, it's all a grand performance by these tectonic plates. These tectonic plates don't just sit still, they're constantly moving and interacting with each other, leading to some fascinating geological phenomena. Imagine two giant slabs of Earth's crust moving away from each other. What do you think would happen? Well, this isn't just a hypothetical. It's a reality taking place right beneath our feet, and it's called a divergent boundary. Now, you might be wondering what a divergent boundary is. It's a type of tectonic boundary where two plates move apart from each other. Picture this: two massive pieces of Earth's crust slowly drifting away, leaving a gap in between. And what fills that gap? That's right, molten lava from the Earth's mantle. This is where things get really interesting. When the lava cools down, it solidifies and forms new crust. It's like Earth is constantly renewing its surface. This process leads to the creation of mid-ocean ridges or rift valleys, depending on whether it's happening under the ocean or on land. One of the most striking examples of a divergent boundary is the Mid-Atlantic Ridge. This underwater mountain range, stretching from the Arctic Ocean to the Southern Ocean, is a testament to the power of divergent boundaries. As these plates continue to move apart, the Mid-Atlantic Ridge keeps growing, reshaping the floor of the Atlantic Ocean. So in a nutshell, divergent boundaries are where the Earth is growing, creating new crust and reshaping our world. Incredible, isn't it? The Earth, our home, is an ever-evolving entity, constantly changing, growing, and reshaping itself. And all this happening right beneath our feet. Now, what do you think happens when two tectonic plates move towards each other instead of apart? Let's explore that thought, shall we? This is where we encounter what's known as convergent boundaries. These occur when two tectonic plates collide, and it's a bit like when two cars collide in slow motion on a geological timescale. Now, you might be asking, what happens to these plates when they collide? Well, typically, one of the plates will sink beneath the other. This process is known as subduction. As one plate subducts or sinks, it forms deep ocean trenches. Picture the Mariana Trench, the deepest part of our world's oceans. That's a real-life example of these convergent boundaries at work. But that's not all. Sometimes when these plates collide, they push up against each other. This creates pressure that results in the formation of mountain ranges. Think of the majestic Himalayas, with their soaring peaks and breathtaking vistas. They're a result of the Indian plate colliding with the Eurasian plate millions of years ago. In essence, convergent boundaries are like the Earth's own way of recycling its crust. The sinking plate gets re-melted into the Earth's mantle, only to be spewed out again later at divergent boundaries. So convergent boundaries are where the Earth is being compressed, creating some of the world's most dramatic landscapes. This is the realm where the quiet yet relentless forces of geology sculpt our planet's most awe-inspiring features. Now, let's take a moment to recap what we've learned about Earth's geological phenomena. We've been on an exciting journey, haven't we? We started with divergent boundaries, where tectonic plates move apart, creating gaps. These gaps often fill with molten rock from beneath the Earth's crust, forming new surface areas, like mid-ocean ridges. Then we explored convergent boundaries, where tectonic plates come together. This can lead to one plate being forced under another in a process known as subduction. The result? Mountain ranges, volcanic activity, and even earthquakes. Earth's surface is a dynamic and ever-changing canvas, shaped by the constant movement of these tectonic plates. These processes may seem slow and imperceptible to us, but their impacts are monumental, literally shaping the world beneath our feet. So the next time you hear about an earthquake, or see a mountain range, you'll know a little bit more about the incredible geological forces at work.